All right, in this video we're going to look at another projectile motion problem. And in a previous video we sort of understood where the equations come from. We're just going to use them now and of course utilize our technology to answer these questions. So this says Charles hits a baseball at 3 feet above the ground with an initial velocity of 150 feet per second at an angle of 18 degrees with the horizontal. Draw a diagram. And then I also should say model this with parametric equations. So here's our diagram. We've got this baseball being hit at an initial height of 3 feet. Okay, so it's being hit at 18 degrees with the horizontal, so let's just say it's something like that. Okay, and so that's 18 degrees, and it's being launched at 150 feet per second. Okay, so we've learned in a prior video that using some trig, we know that A is simply the magnitude times cosine of 18 degrees, and B is the magnitude sine of 18 degrees. You should note that those units are going to be the same as the units of the hypotenuse there, so right, this is a velocity vector. So these are velocities, and they're the horizontal and vertical components of our velocity. From this, we can get our parametric equations. So let's write those down, because those are sort of the source of everything we need. Okay, so it's going to be x of t equals, that is simply my a component there, 150 cosine of 18 degrees times t, and y of t is my initial height plus my vertical velocity times t, and now I'm in feet, so I need this for my gravitational constant. Okay, now again, my students know that I like to store this in the calculator as a letter, so I'll just record. I'm going to put that in as like an A. I'm going to put this in as a B. Right? Draw a diagram. Well, so what we mean here, I mean, that diagram there is sort of the initial moment, but what we also mean is like what's going on here. This ball, it's a projectile motion problem. Right? So the ball starts at 3 feet above the ground, and then it gets launched at that angle. It's going to rise, it's going to fall in a parabolic motion. And so we want to ask a few questions, right? We might want to know how high it goes, so that part of the parabola is going to matter. The horizontal distance, right? So we'll need to know what that is. I think below we have a question about, right? So the maximum height, we've got that sort of covered, right? Looking ahead. When does the ball hit the ground? That would mean we need to analyze that moment in yellow. The maximum horizontal distance, that's also this kind of, that horizontal line, the distance from the launch point. Okay, so that's also something we need to know. And then it says when the ball's 100 feet away, what's the vertical distance? So I don't really yet know where 100 feet away would be. If we assume it's like, I don't know, if we assume it's here, what they're asking is like, how high is the ball? So it would be that moment. So just kind of looking ahead, these are the type of things we're going to want to answer. All right, so this is all going to be basically technology. So I'm going to split the screen. I'm going to put things in the calculator, and we'll take a look. I guess the first thing to note is we're asked what the maximum height is. So we're going to analyze a height versus time graph. Okay, so we're just going to look at our y equation. Okay, the initial height is 3. Time's going to go by. It's going to go up. It's going to go down. We need to know when this happens. Okay, so this is a different parabola than I put up there at the right, but it's going to also, it's going to tell us this time, which we need to know to answer this question. All right, so split the screen here, look at our calculator. Okay, so first thing I like to do is I like to store 150 cosine 18. Again, just note we're in degrees. 150 cosine of 18 degrees. I like to store that as A. And 150 sine of 18 degrees. I'm going to store that as B. Okay. All right, so now I'm going to just punch in my y equation, which I have up there above. It's 3 plus, now I can just write b times x and minus 16x squared. All right, we reflect on my window. So it's being launched at 150 feet per second. Gravity is going to immediately act on it, so it probably wouldn't go higher than 200 feet. And then time, I don't know, how long does a ball stay in the air? Again, 5 seconds is probably fine. So my x is, remember, my time, so that's 0 to 5 should be fine. My y max, let's try maybe like 200. See if that allows me to see what I need. And that looks good. Okay, so I need to find the max height. I need to find this max here. So second, calc maximum. I go a little bit to the left. I go a little bit to the right. Okay, my calculator sort of instantly tells me. So my max, so it gives me two pieces of info, right? It tells me the max, the x value, which is the time, and then the y value is the actual height. And those are both the things I need to know in this question. So when does this occur? So the max height is, so we'll say max height is 36.571 feet, and it occurs at t equals 1.449, we'll say. Okay, there we are. All right, when does the ball hit the ground? Let's write ourselves a little helper statement. The ball's going to hit the ground when the height is 0. So that's going to occur when height is equal to 0, or when y of t equals 0. Now we've got our y of t function here. We just need to know when it is equal to 0. So let me clear this computation. Second, calc, I need to find a 0. Okay, so I go over, I compute this x-intercept. Enter, enter, and that looks like it's happening at 2.96 seconds. So when does the ball hit the ground? T equals 2.96 seconds. Okay, the next question is, what is the maximum horizontal distance of the ball? Well, that is just going to be what my x-coordinate is at this moment, 2.96 seconds, right? That's when it hits the ground. So we know its height is 0 there, but how far away is it from the launch point? We're just going to plug 2.96 into our x equation, right? That's controlling my horizontal distance. So I've already stored that cosine expression as a, so it's just going to be a times 2.960. So I'm going to go to the compute screen here and hit a times 2.96, and I get 422 let's say 27 feet. All right, and then lastly, it says when the ball is 100 feet away from Charles, what is the vertical distance? So we kind of need to know the time value at which it's 100 feet away. So as a helper statement, let's just say, right, 100 feet away, that's when, right, when x of t is equal to 100. But x of t we see above is our 150 cosine 18, which we recorded as at. So that's when a times t is equal to 100. In other words, when t is equal to 100 divided by a. I'm gonna put that in. I'm gonna store that as a different letter. How about like store that as C? Okay, I don't really need to know what it is. So I'm just gonna do 100 divided by my A. Okay, and I'm gonna store that as just a C, so I don't have to record all those values. Looks like about 0.7 seconds. All right, so I know at 0.7 seconds the ball is 100 feet away. What's the vertical distance? Well, it's whatever my height is at that moment. So y of c is equal to, so I got to plug c into my y equation. Now there's a couple ways to do this. If you go back to your graph, okay, I'll clear out all these computations. There's a nice way to do it while we have our graph on our screen, and that is just hit second, trace, or calculate. The first option there is value. And, you know, you can punch in 0.7, but like I've already stored that as C, so I'm just going to hit C. And there it is. It is 27.63 feet. It's the bottom row. I know this calculator is slightly different than some of the TI-84s, but it's close enough. So 27.63 feet, that is the height. Okay, so you can see it's that blue dot on the left side of the parabola here. All right, so this is equal to 27.63 feet, and we are done. All right, so that kind of gave you a nice overview of the type of questions you can ask. Notice everything hinges on our parametric equations, and of course, a good use of technology. Your calculator can actually graph parametric equations. I'll just finish with this comment. If you hit mode, you'll see down there it says parametric, and that would let you graph this thing I have here in, right, I'm going to highlight it in, let's do a different color, but like this green. Right, this parabola, if you want to see that, that's the actual, that's the actual location of the ball at any time. You can do that on your calculator. The reason I don't do that is because it's not easy to compute things in parametric mode. Your calculator doesn't have a lot of functionality in that mode. It lets you like see things and scroll, but it doesn't. It's not as efficient as what I'm doing. So you'll notice we never went to that parametric mode, even though we could have. And it's just because your calculator can't really compute all the things efficiently. So we just do it sticking to function mode. But in any case, this was a nice overview, hopefully, and it should allow you to deal with there we go. Sorry, to deal with the majority of questions that you will come across involving this concept.